Okay, so as promised, we're going to go ahead and do a little bit of help with these transformations. This was our all 4 transformations, and this assignment was given out 9-9 to 3rd block, 8th grade. So we practiced starting today with dilations. For those of you who don't remember, the link for the image of the notes will be posted somewhere in Canvas, but for now, remember that dilation is essentially just taking a scale factor and multiplying it by the current coordinates. Now, this is assuming that we are doing a dilation from the origin, which in 8th grade, that is all that we do. So, for dilation of 2 about the origin, what we need is the current coordinates of m. And m is currently located at +2, +2. Now, in order to do the dilation, we will need to multiply each of those times the scale factor, which is 2. So m prime will be 2 times 2, which is going to be 4. And 2 times 2 again would be 4 again. So m prime would be located at +4, +4. That's m prime. We'll do the same process for n and l. N prime is at -2, +1. So n is at -2, +1. L is at +1, -1. Okay? So now that we have our original points, n prime, we simply double each value because our scale factor is 2. So -2 becomes -4, and 1 becomes 2. Because we're simply multiplying both of those times 2. L, same process, L prime. 1 times 2 is 2. -1 times 2 is -2. So n prime is at -4, +2. -4, +2. L prime is at 2, -2. And there's L prime. So number 1, our dilated figure should look something like this. Just like that. And that's with a dilation of 2. Anytime the dilation or scale factor is more than 1, the shape gets bigger. Anytime it is less than 1, it'll get smaller. So number 2, this one, a little bit different, but most of it is pretty much the same. We're going to start with E, or D, E, and F. So point D, which is at -1, -1. We have E, which is located at -1, +2. And we have F, which is at +1, -1. Okay, we have a scale factor with a fraction this time. So this fraction is going to be 3, 2. So that means for D prime, I am multiplying both of these by 3 halves, or 3/2, or you could take this and turn it into a mixed number, that is 1.5, or you could do it as a decimal, 1.5. There is nothing wrong with converting that. After all 3 of these values are the same. For me, I prefer decimals, so I probably would convert those to decimals, 1.5. So 1.5, 1.5. Oop, almost forgot, those are negatives. There we go. So -1 times 3 halves would be -3 halves. After all, it's a 1. It's just going to be itself. For E, something a little different. For E, -1 times, say, 1.5 would be -1.5. I'm going to continue to write them in decimals, though. -1.5. And then 3/2 times 2. So 3 halves times 2. You might have to write this off to the side. So 3 halves times 2. That'd be 2/1. And that's going to give you 6/2, which is 3. So that's -1.5 and 3. I should point out this is calculator active, so if you need to pull out a calculator to assist with this part, finding those values, you can do that. So that's E prime, F prime. This is going to be, well, 1 times 3/2 would be 3/2, so 1.5. Negative 1 times 3/2 would be negative 1/2, 1.5. Now we just plot these coordinates. In this part, students tend to get a little bit confused. And all you need to remember is that there are half coordinates. And what I mean by that is, trying to get the right color pen here, is this right here is 0, 0. This right here would be 1, which means 1/2 would be right around here. And then between 1 and 2 would be 1.5. And then 2.5, then 3.5, then 4.5. The halfway marks are just going to be between the main lines of our graph. So whenever you're looking to figure out where a half coordinate would go, you can start by making these little tick marks on here. I'm using a gray pen so that they don't show up too dark, and so that way students don't get too confused. And you might have to pause, but I'll hold the video up, or hold the paper up. You can kind of see those lines there. Those are the halfway marks. So, D prime at negative 1/2, negative 1/2, negative 1.5, negative 1.5. Okay, it would line up right here, not on any of the lines. D prime. E prime, negative 1.5 and 3, so negative 1.5 and then up by 3. And F prime would be 1.5 and negative 1.5, so right here. That would be F prime. So my new triangle is just a little bit bigger. It's not much bigger than 1, but since it is larger, our shape got larger. Not like number 3. This will be the last one I do with you on this assignment. For a dilation of 0.5 about the origin, this shape is going to shrink. It's going to get smaller because 0.5 is less than 1. So let's go ahead and write my current coordinates. TUV, so T is at 2, 2. U is currently at negative 1, positive 1. And V, which is currently at negative 1, negative 1. There we go. Now, this one is going to be kind of easy since 0.5 is essentially dividing each of these by 2. We're finding 1/2 of all of these values. So, half of 2 is 1. Half of 2 again is 1. Half of negative 1 is, well, 1/2. So, negative 1/2. And this one I'm going to do fractions just to prove you do not have to do decimals. So, negative 1/2, half of 1, again, would just be 1/2. Half of negative 1, negative 1/2. And half of negative 1, negative 1/2. There we go. So, T prime will be at 1, 1. U prime will be at negative 1/2, positive 1/2. So that would be right here, U prime. And V would be at negative 1/2, negative 1/2. And it will look just like my original shape, only smaller. Half the size to be exact. And that is dilation. Dilation about the origin. Whenever you have that, it will either say that there's a scale factor or it will tell you a number for this type of problem. When you have that, all you need to do is find out what the original coordinates are and then multiply each value, both the x and y value, by that scale factor. And that's it. And keep in mind, this assignment, it does have a backside, but the backside has rotation and reflection practice. Okay? And some translation practice. And that's going to be it. Good luck. Hope this helps.